Hello students, today we are going to learn basic or fundamental properties of the charges. There are only three basic or fundamental properties of charges, only three. So let's explore those three properties. And for Karnataka syllabus, these three properties are very important because they have repeatedly asked the question about this. Uh, for 3 marks or 2 marks repeatedly, so this part is important and guaranteed marks for this from this topic for 3 marks or 2 marks. So they will ask question about the what is this property and explain, or write any three properties or write any two properties. Most of the time write three properties, or they will ask one question about the property and explain this. Okay, let's see the first property we are going to see. Additivity of a charge. Additivity of a charge means you can add the charges algebraically. Why and how? So first thing, why this is important, because this is a charge is a scalar property. So if it's a scalar, there is no problem with the direction, because it doesn't have a direction, no issue with the addition. So if any property comes with a direction, then it is not, its addition subtraction is not easy. We have to follow the rules of a vector addition. But in this case, the property of a matter is a scalar property, that is charges property is scalar. So we can add simply the charges. But it's not simply as we see, because the charges have two types, positive and negative. So what will happen when we add the charges? Yes, of course. The property of a charge we have to consider here. The types of the charges we have to consider when we are adding. It's a simple algebraic addition. So total charge on the system is the algebraic sum of all charges present on the system. For example, if there are n charges q1, q2, q3 and so on qn, then the total charge of the system is addition of all these charges. So this mathematical explanation is just telling us you can add the charges like a simple algebraic sum. Now let's come to the example. So the charges can be positive and negative. If so, the total system of the charge, five charges containing like this: plus one charge, plus two, minus three, plus four, and minus five in some arbitrary unit. So we are not including the unit here. It's not important in this case. So that's why. But all are in the same unit. Now, if we add all this, the addition of this will become minus 1. How? According to algebraic addition, if negative positive, we have to consider in this case. So plus 1 plus 2 minus 3 plus 4 minus 5. So if you add plus 1 plus 2 plus 3 minus 3 plus 3 becomes 0. Now remain is plus 4 and minus 5. So plus 4 and minus 5 is minus 1. So that's why this is looks like algebraic sum, but you have to include the property, or sorry, the types of charges here. Next, second property, and that is charge is conserved. So meaning is charge cannot be created nor be destroyed in an isolated system. Yes, we can transfer the charge one surface to one body to another body. That can be done, but charge cannot be created nor be destroyed. The total charge of the isolated system is always remains constant or conserved, means the charge not be created nor be destroyed. That is, charge can be transferred one body to another. Example. So example, it's a very simplest example is a nuclear reaction. A neutron converts into proton and electron. Yes, proton is a positive charge but not antiparticle of electron, or both are different particles. Only same are in a electrically charged. These two particles are electrically equal in a magnitude. The proton and electron thus created have equal and opposite charges. The total charge is zero. Yes, for example, proton is 1.6 into 10 raised to minus 19 coulomb, and electron will also have the same magnitude, 1.6 into 10 raised to minus 19 coulomb. But one is positive, another is negative, so addition of these two charges becomes zero. Yes, those are not destroyed, but their total addition of the system is zero after the creation. Whose creation? Neutron is plated. This is not a charge is created. This is a particle created creation process. And when the particle is born, of course, the property comes by birth, and that's why it is called intrinsic property. Now, let's move on to the next property, or last property, that is quantization of a charge. So, quantization of a charge meaning is what is the quantity of a lowest quantity of the charge, and what is exactly quantity of the charge? 1 coulomb, 2 coulomb? No, smaller than that. Then how much? So the smaller quantity is found by electron, because electron is the very smallest particle compared to other particle. We are not talking of in particles inside the nucleus. There are no particles inside the nucleus which have the charge except proton. Yes, there are cores and all those other things, but their property, their chap, they do not come with the polarity of like this. Okay, so there, that's why the lowest value of a charge is electron. So how much electron is carrying the charge, magnitude of electron? So it is found that all free charges are integral multiple of, this is a definition or statement of quantization. So what it means, all free charges integral multiple of basic unit of a charge. So what is the basic or lowest value of a charge? The lowest charge of the body according to that statement. Thus charge q on the body is given by q is equal to n into e. So what is the e value? So e value is found to be, E value is found to be 1.6 in 602,192 into 10 raised to minus 19 coulomb, approximately equal to 1.6, or rounded off 1.6 into 10 raised to minus 19 coulomb. So this is lowest value, and that is called quantization of charge. So we found that we determined that it has a quantity. Now what is that quantity? This is why this is, because it's the lowest, below than there is no such value of a charge. Now, what is n? It is just mean positive or negative integer. For example, 2 electrons, 2 into this value. If there are 3 electrons, 3 into this. So, charge is basically represented by Q. E is represented as a lowest value of a charge. This is quantization of charge. Okay. So, these are the three properties which are repeatedly asked in Karnataka physics exam. But there are few other behaviors, actually we can call properties, but those are not properties. So those behaviors we are going to learn as nature of electric charge. So what do you mean by nature of electric charge? How the charge will behave, that is what nature of electric charge or characteristics. So like charges repel and unlike charges attract each other, we already seen. Charge has only magnitude but no direction, that is scalar quantity. Yes, we know that. Charge is unaffected by motion, meaning if the charge becomes in a motion or it is in rest, its electric property does not change by motion. Charge always presents under the outer surface of a conductor. Yes, charge is always present on the surface. Thank you.